This lesson is going to specifically look at a specific type of functions. Those functions are called directly proportional functions. In order for the function to be directly proportional, it has to have a rate of change that is the constant of proportionality, and the rate of change is steady and unchanging. Another word for the rate of change is slope. So basically, it has to have a constant slope. In order for another aspect, in order for it to be directly proportional, is that the equation has to be in the form y equals kx. Also, its graph has to be a straight line, which is why it has to have a constant slope, and it either has to begin or it has to pass through the origin, and the point that's the origin is the center of the graph, which is also known as 0, 0. So some of these you see in the examples below are directly proportional functions. All of the equations are directly proportional functions because they're all in the form y equals kx. And all of the graphs are examples of directly proportional functions because the graphs are linear and they all pass through the center point, the origin. So let's take a look at some examples and decide if we have examples that are directly proportional or not directly proportional. So if you look at the equation y equals 2x plus 8, that is not directly proportional because it's not in the form y equals kx. Let's look at the table. So the table does pass through 0, 0, but you have to look if it has a constant slope. Another word for constant slope is common difference. So it has to increase by the same amount each time as long as the input values are consecutive, meaning in order 1, 2, 3, 4, 5, etc. So if we're looking at how much it increases by the common difference, if there is one, so the difference between 3 and 0 is 3, between 3 and 6 is 3, between 6 and 9 is 3, between 9 and 12 is 3, between 12 and 15 is 3, and then between 15 and 18 is 3 as well. So that is a directly proportional function because it has a constant slope, which means it's linear, and it passes through the origin. This equation is directly proportional because it's in the form y equals kx. This graph is not directly proportional because although it is linear, it does not pass through the origin, the point 0, 0. This table is not directly proportional because even though it does pass through 0, 0, there is no constant slope or common difference because from 0 to 6 it increases by 6, but from 6 to 2 it decreases by 4. That's not a common difference or a constant slope, so it is no. That line is directly proportional because it goes through the origin and it is linear. This equation, y equals negative 3x minus 4, is not directly proportional because it does not, or it is not in the form y equals kx. If we're looking at this table is not directly proportional because it does not go through the origin 0, 0, it goes through 0, 2. This graph is directly proportional because it is a straight line and it goes through the origin, the point 0, 0. This equation, y equals x, technically is yes because it is in the form y equals kx, because when you have a variable and there's no number out front, no coefficient, we can assume that that coefficient is a 1. So y equals x is the same thing as saying y equals 1x. So it is technically directly proportional. We just do not very often write the 1 in front of the x if there is only one of them.